we'll start the proceedings, I think. Excellent. So welcome everybody to tonight's meeting of the Astronomical Society of Edinburgh. Tonight, our main talk is our member Bruce, who's going to be talking about the Venus tablets of Ammisaduqa. He did berate me for showing a picture, but I did suggest that there weren't many cuneiform readers in the audience, so he probably didn't give too much away. That'll be followed by scope talks. We've had a series of talks from members about their scopes or equipment, and tonight we've got Pat and Hugh who are going to talk to us about their equipment. But first of all, perhaps we can welcome, I think, 7 new members tonight. I think it's probably the most we've had in one batch for a long, long time. Can we welcome Linda, Craig, Forbes and Francis, Byron, Radim and Alan? If you can unmute, please. So very welcome to you all. And you'll note the picture on the right, we are also celebrating today the launch of Apollo 16, which took off in 1972. So, for those who are watching on YouTube and are not members, you can stay in touch with us. There's a whole host of information on our website, and you can follow us on Facebook and on Twitter. And if you want to look back at any of the talks we've had during lockdown, and there's a lot of them now, they're all available on our YouTube channel. And what have we got coming up? Well, on the 7th of May, we have Planet 9, or Planet 9, Discoveries in the Outer Solar System, and The Sky in May. That'll be Dr. Samantha Lawyer and Alan Pickup doing those. On the 12th of May, it's members only, it's the Imaging and Observing Group. And on Thursday, please note Thursday, not Friday, on the 20th of May, Professor Catherine Haymans will be talking about the dark side of the universe. And that promises to be, I think, quite a special meeting. So I'm looking forward to that. On the 4th of June, with the the South African Large Telescope Observatory, and it's our AGM. So we'll have the talk, the Sky in June, and then it'll be closed for members only for the annual general meeting. On the 18th of June, we've got Tom Field joining us from Seattle, talking about spectroscopy. And on the 2nd of July, Professor Giles Hammond of Glasgow will be talking about asteroid light curves, although that title might change. So a whole host of things to look forward to. So with that, I'm going to hand over to Bruce. So if you want, I'll stop sharing, Bruce, if you want to stay. Oh, sorry, I'll stop sharing.
Yeah, right. Now I did try to start even before you stopped. Here we go. Yes, I think we're in business. I can't see myself in the corner here. I can only see you. That doesn't matter, I guess.
That works fine.
So tonight, welcome everybody to tonight's talk, which is entitled The Venus Tablets of Ammisaduqa. Now, Ammisaduqa was a king in Babylon at, let's say at this point in time, at an unknown time in the past. That's what we're going to try to find out. Because during his reign, I've just clicked, but nothing up. Oh, there we go. Because during his reign, this tablet here, which Andrew showed you a moment ago, which is hanging in the National Museum in London, was written with observations of the planet Venus. And these are very precise observations. So they give us a chance to find out historically when those observations occurred. And in 1912, the tablet was found around about 1850, but I'll say a bit more about that in a moment. In 1912, somebody translated a particular line off this tablet, which said, "Year of the Golden Throne." And other workers in the field knew that that was the 8th year of Ammisaduqa's reign. Hence, can you all hear? Oh, hence, we now have a connection with this tablet with Ammisaduqa. So if we can solve the actual moments in time that these astronomical observations were taken, we know when Ammisaduqa was on the throne, and the archaeologists will love us. It's written in cuneiform. I'll just give you a small example of cuneiform here, which is very, very fine handwriting on a clay tablet, which is not much bigger than a mobile phone. It's the earliest form of writing known to man. It was invented in the Babylon area, or Mesopotamia as it's called, about 2,000 years, even before this was written on these tablets. So I now move to the history of the tablet itself. Oh, although I talk in plural with tablets, there was only one tablet, but it was being copied several times. And so there's more than one tablet in existence. A king, around about 1,000 years after Ammisaduqa, a king by the name of Ashurbanipal had this bright idea of collecting all of Babylon and Mesopotamia's clay tablets with writings on them together into one library, which he put in Nineveh, which is where he was reigning from at that point in time. Unfortunately, in 610 BC, 12, sorry, it was sacked, Nineveh, just razed to the ground practically. And the library was set on fire, and it's assumed that the tablets were on an upper floor. When the floor gave way, they crashed to the ground or the basement, creating the world's biggest jigsaw puzzle. And that's why the tablet is cracked. And fortunately, there are 3 known ones in existence. 2 of them were found at Nineveh and 1 later at another dig, but they're all broken in different places. And the tablet has been largely reconstructed in full. This is a geographical area of where things were happening. And Nineveh is up here on the Tigris River, Babylon down here on the Euphrates. So the tablets were created here, shall we say, and then found their way up to the library here before they were all broken. And this is modern day Iraq. So summarizing what we've got here, we've got fragments of clay tablets found in, I've got Babylon there, but it was Nineveh around 1850. They contain positional information for Venus over a 21-year period, registered by day, month, and year, starting at year 1 in their calendar. And this was typical of what was done in antiquity. Each time a new king came to the throne, or a pharaoh in Egypt, they started at year 1 again. So when archaeologists are piecing all this together as history, they add up all the numbers of years that kings reigned for to get the full picture. Its importance, well, because it's got precise astronomical information on here, if we can crack that, we can actually date Babylon literally to a year and Ammisaduqa. So that's the name of the game. I was handed this problem by Ken Thomas when he was the president of the ASE around about 5 years ago, and I did some work on it then and gave a little 20-minute talk. But I've resurrected it in the last 2 months and spent a bit more time trying to put more of it together. And these are the steps that I took with the tablet. Firstly, create an outline Babylonian calendar. We need a calendar, so we need to understand the Babylon calendar. Populate this calendar with the Venus sightings. Extract the timeline of the Venus sightings by number of days from that calendar, and then find this blueprint of the sequence of these events in our calendar. And then the job is complete then. We have to take these sightings across into our calendar, find the place that they fit. It's all made possible because of this book here, written by Jean Meus in the 1990s. Meus is a chap that works with NASA on quite a lot of projects. And this book, which I've owned for about 12 years now, I think, has got algorithms in it that you can use to create accurate celestial positions between 2500 BC and 4000 AD. Now, we do know that Ammisaduqa is around 1500 to 1700 BC. That's well within the capability of the algorithms in this book. And in particular, we need to know exactly where the moon and Venus were, as you'll see shortly. And the algorithms are believed to be extremely accurate for those. It's based on NASA information, and these are the very tables that they use for firing off their rockets in the solar system and getting them to the right place, but they continually refine them. And one of the really nice things about this is that when the US government set NASA up, they told NASA that anything they found out about celestial navigation and celestial mechanics would be in the public domain, which is great. That means you can log into NASA and you can download this type of information, but you don't need to with a book like this. It presents you with what you need. Right, what's the Babylonian calendar then? Well, it's a lunar calendar. It has got nothing to do with the sun. It's a lunar calendar of 12 months. I won't pretend to try and read them out. Often written in Roman numerals, strange to relate, even though the tablets are in their own language. But a lunar calendar, the first day of each month in the calendar is the day after they see the crescent moon at sunset. And I heard people muttering about that just before we started, that they'd seen a crescent, and I'll be demonstrating that in a few moments' time. So that's the important day in the calendar when the new month starts. And I hasten to add, by the way, that Islam still uses this calendar to this day, and all of their big dates are taken from this calendar and not from our solar calendar. But we know that the average period of the moon, called the synodic period, is 29.53 days. So that's an average number, by the way, but it's pretty close. You don't need very many months for that average to pop out. So if we take 12 months here of 29.53 days and we multiply it up, we get 354 days and a bit. That's short of our year by about 11 days. So if they do nothing about their calendar, then it's going to inexorably move through the seasons as it goes forward, because we're going to be 11 days short every time we have a year. To counteract that, they add extra months in. They add an extra month in when they need one, either after month 6, Elulu, or month 12, Adar. And I think it's a random selection when they think they need one. So they put the extra months in. Now, these months are called intercalorie months. That's a technical name for them. And indeed, when we have the 29th of February in our calendar, we call that a leap day and a leap year. The technical term is that it's an intercalorie day. It's a number that's placed in the calendar to keep the calendar accurate. And of course, since their calendar was 11 days short with the 12 months, and you multiply 11 by 3, you get 33, which is not far from 29. You know, they're putting in an extra intercalorie month around about every 3 years. And they always put it after one of these two. Now I'm going to go off the air for a moment. I want to show you something about the moon and their calendar. Okay, it's already been said. I'm going to go back. That map is today's map in Babylon, but let me go back 4 days because that's when the new moon occurred, the recent new moon occurred. And what I've got here is a representation of the horizon with the sun on the horizon. And just here, you can make out with a red cross, which is the center, geometric center of the moon, a little ripple of bits of yellow for the lighting of that moon. This is the first crescent after the new moon. Could they have seen that? Maybe not. So if I go 1 day forward, it's now a bit this big, and go another day forward, it's this big, and another day. Now, they're bound to see it at that point. It's been seen here in Edinburgh. In fact, as you've heard probably earlier in the last couple of days. But remember, this is Babylon. We're about 3 hours behind it. So if I go back the days now, that would definitely have been a crescent that they would have seen, thereby generating the first day of the month. But this might have been a crescent that they saw. We don't know because we can't go back to Babylon and ask them. And I'm pretty certain they wouldn't have seen this one. So the name of the game is to create a Babylon calendar back in the days that we're interested in and also figure out when they could have seen that crescent moon. So I now want to change back to the other screen. Right, I think we're there now. Now we'll go to the next slide. There is a mathematical formula that has been generated over a few hundred years now of people interested in solving the problem of when you could see the first lunar crescent. And of course, it's of importance to Islam even today. So this is, I'm about to go through some work that is probably being done for Islam these days. It's called Arcus Visionis. I'd never heard of it until I started this project. And there are two parameters that determine whether you can see the lunar crescent. Parameter 1, which is called the arc of light, that's the angular distance between the sun and the moon, because that determines how big the crescent is and therefore how much light we're going to be seeing. And the arc of vision, which is the depth below the crescent moon to the sun, because where the sun is after it's sunk below the horizon determines how dark the sky is so that you can see that crescent. And over the years, as I say, there have been mathematical formulae for this. And the most recent one, which I've been using in my software, comes from the Nautical Almanac Office of the UK, actually, by a chap called Yallop. And people are now using that algorithm. And what this means is I can use the capabilities of the software from the Mias book to predict where new moon will be, all the way back to 2500 BC. And then I can go forward day by day after new moon and apply the algorithm to see when they first saw the crescent. Hence, I can create a pretty accurate Babylonian calendar. Let's have a look at the tablet contents now. So we know I can make a calendar. Let's look at the tablet contents. Now, the tablet contents are very specific positions of Venus, 4 to be exact. They watched while Venus sank in the west and then was extinguished when it got close to the sun. And they noted that down, first day of invisibility. And then they watched in the east till it rose, and they wrote that down. So they've got a number of days invisible. Then it goes to elongation in the east, back down, sets in the east, and now they record when it rises in the west. So they have 4 parameters for each total circuit of Venus. And here's the sort of thing that's on the tablet. These are exact positions from the tablet. In year 1 of Ammisaduqa's reign, Venus went invisible in the west in the month of Shabbatu, the 11th month, on day 15 of that month. It became visible in the east, also in Shabbatu on day 18, so it was invisible for 3 days. And in the second line here, we see that it then went invisible in the east in month 8, Arasamu, day 11, came back in month 10 this time, Tebetu, day 19, and that's 2 months and 7 days. It's an awful lot longer than the 3, you'll notice. The arithmetic doesn't look quite right, but it's partially due to the fact that some months are going to be 29 days, some months 30, and some 31. And they will have counted the number of days accurately for here, irrespective of what these dates are. And then we go to the 3rd and so on. So that's what we're shooting at, trying to find when Venus was on the horizon back in the days of Ammisaduqa, and hence solve the problem. Now I want to go to my other screen again. This one. This time I'm going to show you the orbits of Venus. Now let me start them up. What we have here on the left is the sun in the center, Venus and Earth. And this is a very accurate model, by the way, using Mias's book. But watch up here for the moment. Notice how when Venus comes close to us, it's huge, but it's black. And in a moment, it'll accelerate away. I go fast in the bits we're not interested in. And it'll go fast now, it'll shoot right away, okay? Until it's only about 1/7 the size when it was close to us. And I'm going to pause this in a moment because when it's at its furthest point, which is about now, when it's at its furthest point, it's lit full because the sun's light is bouncing off it back to us. And this is called superior conjunction. It's at its furthest point from Earth. And of course, Venus is now in the glare of the sun, so we won't see it. Now, if I resume this and we come back round again, we'll then be at inferior conjunction when it's close to the Earth. So we get them in a straight line again when they come around, and it's quite big. And I'll just stop it in a moment. Right, there we go. Now that's inferior conjunction. They're in a line, but it's close to the Earth and it's very large. But it's black because it's being backlit by the sun now. But if I just resume this for a few days, right, you'll see that there's a crescent building up. And unbelievably, that crescent is big enough and bright enough that Venus is brighter here than when it's over at superior conjunction. It's absolutely amazing. So we can see it quite easily when it's rising and setting, when it's in inferior conjunction. Now I want to go around twice more, but hang on. I want to change now to the geocentric view of this. In the geocentric view, we have the Earth at the center, and the sun is therefore going around the Earth, and Venus is going around the sun. And it's a bit easier for us to visualize now what Venus is doing with respect to us. Let me just resume it. Now, when Venus gets onto the outer here, when it's at, I'll stop it just there. It's coming up to superior conjunction here. It's away from the Earth. Notice that the sun is going anti-clockwise, and so is Venus. So when I resume this, both of them are going anti-clockwise all the time. So, but Venus is going faster. So it catches up with the sun and then passes the sun, and we can see it again. So we don't see it for quite a long time when it's at superior conjunction. And then I'll let it come around to inferior conjunction now. And a couple of things happen at inferior conjunction that happen quite fast, and you'll find difficulty of spotting it. You might have noticed already, let me stop here. You might have noticed already that I've drawn Venus in red sometimes. When we get near inferior conjunction, Venus goes into what's called retrograde motion. Because of the differential in the speeds of the Earth and Venus, Venus is actually going backwards. So although normally Venus and the sun are both going anti-clockwise, for about 40 days, Venus goes clockwise. And that's when I color it red. It's very difficult to see, but well, let's have a look and see if we can see that. There it is. It's going anti-clockwise at the moment. So what this means is, that's about 40 days, and it'll go back to being clockwise in a moment. What this means is that at inferior conjunction, they're passing each other. It's quick. But at superior conjunction, they're going in the same direction, and Venus is catching up and passing. Now, I want to go back to the other one now. This is the last time we need to do this. Right. Now, I'm going to go on to let me just go back one slide for a moment. So you can see the meaning now of why we got small numbers and big numbers. At inferior conjunction, we get small numbers. At superior conjunction, we get big numbers. Now, we need to know about the Arcus Vigilis of Venus, because what I have to do when I'm trying to model this in mathematics is not only know where Venus is, but what day would they not see it? So in this case, unlike the moon, because Venus is quite a long way away, we don't have the arc of light, because although it's a crescent when it's quite close to us, we just see that as a blob of light. It's not like the moon. And so that blob of light's got to be light enough for us to see it. And the arc of vision is the only parameter. Researchers use about 6.5 degrees, sometimes maybe 6, as being this angle here, below which we can't see Venus in the glare of the sun. But I found one researcher using a unique value for every setting of the rising and setting points to try and get the solution to this problem. So here's the full tablet. I only showed you a bit of it the last time. There's 26 entries in 21 years. And they're going between inferior and superior all the way down. And I want to now create an outline Babylonian calendar to put these observations into. And it's actually quite a simple operation when you get to think about it. And I just did it in an Excel spreadsheet. I didn't need to write any software for this. what I did in the Excel spreadsheet was I gave myself 21 years worth of 12 months. So that's the 21 years of the Babylonian calendar that I'm interested in. Now, there's no intercalorie months yet. I've just got the raw months there because I don't know where to put the intercalories. So the full 21 years is going to be short of 21 solar years by about 240 days. But we'll see soon that I can actually sort that out. Now, because although I've gone through the motions of showing you how I can create a Babylonian calendar, because I don't know the dates of Ammisaduqa's reign yet, that's what I'm going to try to find out. I can't make an appropriate calendar. So what I did was, I decided that no matter how they set the days of each month up, they always average 29.53. So I said to myself, every month in their calendar will be 29.53 days long. And over the 21 years, that all works out in the wash. It's going to be slightly wrong sometimes. And of course, it's not an integral number, but that doesn't matter because I'm looking for elapsed times in days on the calendar, as we'll see in a moment. So the first day, Nisan there is the first month in the first year. That is my baseline day 0. AR was 29.53 days later. Simanu 59.06 later. Dumuzi 88.59 and so on, right up to about 7,200 odd. And then I populated this Excel spreadsheet with the data from the tablet. And the first entry on the tablet was month 11 of year 1, Shabatu. Now Shabatu started 295.31 days after my baseline. It's an inferior conjunction, went invisible on day 15, came back on day 18, 3 days. So if I add 15 days to the start of this month, I get 310.31 here. That is the exact number of days since my baseline that Venus first went invisible. Now I divide this number by 2, because when it becomes, because in between invisibility and visibility, it's going to go to the conjunction point. And with a number as small as 3, adding 1.5 to this is a pretty good guess. This will be the first inferior conjunction after my day 0. And if I just go down to one more here and show you that Arisamu, which is now in year 2, month 8, it's 561.08 days from my baseline, but it disappeared at day 11. So I add 11 to that and get 572.08. But it reappeared in month 10 here in day 19, 2 months and 7 days, which is about 66 days. Divide that by 2 and I get 33. So I added 33 to this number here. And this should be the first superior conjunction, approximately. I then got the difference between this number and this number here, because this number should stack up with the behavior of Venus that I can work out mathematically. And then when I go to the third one, work it all out the same way, but I add an extra column for the third one, which is the difference between the first one and the third one. That is now the full time period between one inferior conjunction and the next inferior conjunction. And that's about 583.9 days on average. So I like a number around 583 here. And 577 is pretty good. You know, that's a good answer. But there's no intercalorie days here. It all worked out mathematically for me. But let me go to page 2 and we'll see what happens there, because I've got an NB here and an NB here, because I had to put an intercalorie in here and one in here. Now, why did I put an intercalorie in there? It's because this day here, this number of days from the superior to the inferior was about 30 days short of what it should be when I mathematically look at the behavior of Venus. So I put the intercalorie in and it pumps itself up to a nice date. And this is a wee bit high actually, but at this stage in the game, that doesn't worry me too much. And the same thing happened down here. This was 550 days. So I needed an intercalorie to get that bumped up. And I didn't put it in this group here because I also found this number was a bit short. So I put the intercalorie up here, got this number up to what it should be for Venus, and brilliantly got that number up to what it should be for Venus. So I carried on in this way down through the calendar. And so in summary, the way I built the calendar was start with a raw calendar with no intercalorie months in it, then use the properties of Venus to tell me where to put them. And I've now got a nice consistent set of data. And what I then did was, I'm not interested in these blank lines. I'm only interested in these lines here. And for this line up here, I popped this 3 up here and the 2 months and 1 day up there, just to compress it all down. And I then had the 26 entries where I've calculated elapsed days between all the events. So this event actual here was the moment in time from the tablet when Venus went invisible, be it at the west or the east or the west again or the east again. My adjusted day was when I added on half the amount of time it was disappeared for to get what I believe will be the conjunction dates in sequence. So I saw my first conjunction after 311 days, and then the next one was 605 days after the beginning, etc., right down to 7,600. And I got the interior differences here in this column. That'll be 311 off 889 for that, 889 off 1486 for this, because I wanted to just check that these were all roughly 583 plus or minus a reasonable number. And they stack up reasonably well here. Now I've got my calendar that I'm very happy with. And I extract the information that I really want now, just clobbered it down. So I've got the type of conjunction here. And the durations here, they're important because I've got to find them mathematically in our calendar. These differences are important for me to just spot by eye that they look good. But this is the real data here that I have to fit into our calendar. And I've subtracted 311 from everything. So the first inferior conjunction occurs on day 0. 293 days later, I should have a superior, 577, an inferior, and so on. So when I take this across to our calendar and I place it somewhere on an inferior conjunction that I've worked out mathematically, it should spread down neatly and slot in and give me all the conjunctions like they are here. And as a check, I then use maths to find out how long it should be invisible, to confirm that I've got it in the right place. And hey presto, I've got an answer. But it doesn't work. It doesn't give me anywhere any answer that jumps out at me and says, I'm the answer. There's always some rogue observations. And other workers, this has been worked on for about 100 years now. It was the 1920s when they started working on this. Other workers have found the same thing, but they were working on previous tables that would be now out of date. In the 1920s, we didn't have Mias's book to tell us how to go about it. Now, I've pulled this off the web. These are the favorite chronologies that the archaeologists really like. And I've popped Reign of Hammurabi into here because he's Mr. Big. He is the one they are really interested in. He's the big king of this dynasty. But of course, we have our little king down here, and he's very important because we can probably get his date, so we work hard enough at it. And they've got 4 favored chronologies that various archaeologists throw up and say, this is what I think it is. They're called a high chronology, a middle chronology, a low, and an ultra low. And that's these numbers here. So naturally, I tried to slot my solution, all my numbers from my Babylonian calendar. I tried to slot them in at 1702, 1646, 1502, and I couldn't get anything that jumped out at me. They're all equally good or equally bad, whichever way you want to look at it. And indeed, I did this calculation right from 2000 BC to 1000 BC, a whole 1,000 years. And I couldn't get a single year in that 1,000 years that fitted the observations in such a way that it was like a glove. So that's rather sad, and I've just summarized that there. I couldn't find any date in 1,000 years that I could be happy with. So these are the ones that reign supreme, shall we say. Now let's have a look at the properties of Venus to see why we're having trouble solving this. First of all, the synodic period. That's the period from inferior to inferior and also from superior to superior. And as I've noted earlier, just verbally, The inferior is 583.9 days and the superior 583.9 as well. That's an average. But the smallest inferior and the largest inferior are only 4.5 days away from that. That's about 1%. It's very small. And in the superior, we get a little bit better. It's about 9 days or 9 and a bit days. That's between 1 and 2%. So we're not seeing a big variation in the trip of Venus around the sun to actually tease out small numbers of days in this calendar. So that's one of the things that goes against us. And there are two other things that are quite important. The first one of which is very good, and the second one of which is extremely disastrous. The angle, Venus's orbit is inclined to the ecliptic by about 3.4 degrees. This is a good parameter because if you remember back to some of the numbers I was quoting for the inferior conjunctions in particular, they were going from 3 days up to 20 days. That's quite a lot. And I think that you can take it that the 3-day ones are where Venus is quite a long way out of the ecliptic, near its 3.4 degrees, when it comes past the sun. So it comes past quite quickly. And for the 20 degrees, Venus is probably close to the ecliptic itself, and it's going through the sun as in a transit. So you've got a longer journey, 20 days instead of 3. So that's a good parameter because that gives us a footprint of different numbers that we are looking for when we insert everything into our own calendar. But this last one, this is a killer blow. 11 orbits of Venus is approximately very close, actually, to 8 orbits of the Earth. And the upshot of this is that if you get a solution, if you add 8 years to it, you get another solution, which might or might not be as good as the one as you had. And you add another 8 years, you get another solution. And if I go back one slide to here, here's the favored solutions for Ammisaduqa. And if we look at the first year of his reign here, 1702 for this solution, and the first year of his reign here for this solution, that's the middle chronology, you subtract those two, you get 56, which is 7 lots of 8. And if you subtract these two, you get 64, which is 8 lots of 8. And if you subtract these two, you get 32, which is 4 lots of 8. So they're paying lip service to the tablet because they've got multiples of 8 between all these solutions. So they've looked at the tablet, but the other dates are a guess, I'm afraid, based on what they've read on the other tablets. And here's the real killer blow from my point of view. Here are the 26 readings from the observations from the tablet. And I'm highlighting the 9th one and the 13th one here in yellow, and I've got a couple more down here. But if you look at the 8th and the 12th there, the 8th, I calculate mathematically using all the Mir stuff, 15 days of invisibility, and they have 7. I calculate here 18 and they have 11. This is for the 1646, the middle chronology, the one they like. It's 2 years out here, but he came to the throne 1 year later than the first one, and minus 1644 BC is 1645 BC when you count 1 instead of 0 before Jesus Christ. Anyway, if you look at my calculated ones and the tablet and the tablet ones, 3 and 3, that's fine. 48 and 67, that looks bad, but remember I said that the Arcus Visionis for Venus would be about 6.5 or 6 degrees. If I use those numbers, I get a number here that's pretty close to 67. But I don't want any of my numbers to be bigger than the disappearance that they saw, because that can't happen. I can't mathematically say it's 15 days and they only saw 7 days of invisibility. It just doesn't, that's not right. That can't happen. My numbers have got to be less than theirs. So I pulled the Arcus Vision in down to 5 degrees to make sure that I was getting an underestimate of the number of days that it would be invisible. And it's quite fine up to this point, 18, 20, 43, 61, 10, 15, and so on. Bang. Now, the same one here. Now, I've gone over 1,000 years with this, and I can never, ever get that number less than that number. Even though I'm using a highly optimistic Arcus Visionis, it doesn't happen. And I think other workers probably found the same thing. And for this reason, it's really impossible for me to say any solution is right. And the same thing happens down here. I've got light orange down here. These ones are also a bit rogue like these, but they're always a bit closer. I can never get them inside, but they're closer. And that's really why I didn't solve it at the end of the day. And that was where it would all have ended. But I sat back when I got to that point, you know, and I'm going to have to give this talk, and it's going to be a depressing talk because we don't get a solution. And I looked at two readings. When you first pick up this tablet and you look at it, on day one, there's two readings on that tablet, two observations on that tablet that jump right out at you as impossible, that it can't happen. And everybody up till now, and myself included, when you're trying to solve the tablet, you just ignore them, throw them away. You know, they can't be right. But everything I was looking at took me back to Egypt, where I've done talks on Egypt before, and I know a little bit about Egypt from some evening classes I did years ago. And the ancient Egyptian timeline for the really big dynasties runs from the Old Kingdom at around 2686 BC to the New Kingdom around 1070 BC. This is where all the great pharaohs lived. This is when they built the big pyramids. Down here was when they hid their pharaohs in the Valley of the Kings, because the pyramids are pretty good signposts saying that the loot is in here. And they probably lost an awful lot of stuff before they worked out to do this. However, the interesting things are the first intermediate period and the second intermediate period, because they are periods of great chaos in Egypt. And I've done a talk on the first intermediate period in the past, but I'm interested in the second intermediate period right now. And what's interesting about this, and this is why it came to my mind, is that the dates of the second intermediate period that are published, and some of them go back to 1700 BC as well, these dates are where we're looking for Ammisaduqa. And because I knew something about this second intermediate period, when I was looking at these rogue entries, my mind came back to Egypt for a particular reason. And let's have a look at that. Second intermediate period was a time of great chaos in Egypt. Egypt was invaded by a group called the Hyksos, and they kind of took over. They set up a capital city in the Nile Delta area, and they ran Lower Egypt from there. Upper Egypt was left largely alone, I think. But modern thinking is that this is the time of the Exodus, when Moses took the Israelites to the promised land. And I think if we all went to Sunday school, we probably have learned about God helping Moses, of course, because he didn't like the Egyptians. He sent the 7 plagues to Egypt, allowing the Exodus to take place. Now, I don't know about you, but when I was sitting in Sunday school, listening to all this, I thought it was a complete fairy story. But these modern historians think that there's a causal link to the plagues by volcanic action. They can explain every one of these 7 plagues, and I'll not go through it blow by blow. You can find it out on the web. They've explained every one of these 7 plagues as a result of a volcano going off. And we do have a volcano in the area. It's called Santorini. You may even have holidayed on this island. It's a Greek island. And it's many years ago, it had a big mountain called Thera. And sometime in between 1500 BC and 1650 BC, which are the popular dates, it went off, and it was a big one. So it's a volcano in the Mediterranean. How big was it? Well, volcanologists are like those who look at earthquakes with a Richter scale, but they have one called the Volcanic Explosive Index, a VEI, and it has values from 1 to 8. It's open-ended. 8's just the biggest one they've ever found. And it's a factor of 10 every time you go up 1. So a VEI of 2 is a volcano that's 10 times bigger than a VEI of 1, etc. The biggest volcano that we all kind of know of in modern history is Krakatoa, 1883. It had a VEI of 6, so it's a big one. And Krakatoa was a volcano that just went bang in a one-up. It didn't it didn't have lava and clouds of smoke and stuff like that. Well, it may have, but it just went bang and made a big mess. Santorini is the same, but bigger. It had a bigger bang, about 10 times bigger than Krakatoa. And incidentally, the bang of Krakatoa was heard in Perth, Australia. So it wouldn't surprise me if the bang of Santorini was heard in Egypt and in Babylon, if indeed it gave a huge bang as it went off. So it really, this is a big volcano, and it would have thrown, like Krakatoa, it would have thrown a lot of dust into the atmosphere. We had, in the Northern Hemisphere, quite red sunsets for many years after Krakatoa. And so this sort of thing would have happened after Santorini as well. When did it go off? Well, I gave you some dates already. Unfortunately, it's enigmatic. It's unbelievable. You'd think they knew about all volcanoes by now. But they've got probable dates between 1650 BC and 1500 BC, which happily encompasses nearly all the proposed dates of Ammisaduqa. And this brings me to why I went down this alleyway. Here's the tablet observations, and I've arranged them slightly differently. I've got all the inferior ones up here in chronological order and all the superior ones down here in chronological order, and I've highlighted one of each. If you go down the invisible days for the inferiors, like 3, 20, 15, 3, 7, 4, 11, 7, 46, 15, 4, 15, 7. Sticks out like a sore thumb. I mean, when I saw that number, I thought, well, that's a rubbish observation. And then if we go down to the superiors, 67, 61, 64, 71, 67, 60, 166. Bingo. That's odd as well. And even if you go down a bit further, there's one at 99 here, which I could have highlighted, but I'm not comfortable with that data point. But it doesn't matter. We've got 2 here anyway. These 2 observations are a volcanic footprint. Why? Well, when we look at this 46-day one here, which is only supposed to be 3 days, by the way, or 5, depending on what you use as the Arcus Visionis. So it's meant to be quite a small one. I looked at each end of it to see if they got the ends right. One of the ends right and the other one was wrong for some reason, and that's not correct. Inferior conjunction was bang in the middle, 23 days each side. And if the same thing happens down here, I look very carefully at this entry, and as it happens, superior conjunction is bang in the middle of these 2 dates, 83 days either side. And this reeks of dust in the atmosphere, because when you see Venus rising, for example, it's coming into, you're looking at the horizon, and it will be extinguished behind a long amount of dust that you're looking through at the horizon. As it rises in the sky, it'll be coming up out of that dust, and you'll be looking through less dust, and eventually you'll see it. Same thing when it's setting, disappears somewhere up in the sky because it's now going to go behind enough dust that we can't see it. And so you get a long period there. Now, these 2 readings, observations, are about 3 years apart. So I would go, if I were putting my money on it, I'd say that Santorini went off in 2 parts, quite a big one, and then another one which was not as big. So there's a hypothesis that I've got there that this is volcanic action. Now, let's have a look at the last slide now. Here's my first point. Why is this the only tablet that we've got? I mean, I went back and did some more searching, when I got to this point, there must be other tablets, there's not. And if there are, they've got them on a shelf somewhere. They haven't been programmed into the internet. And I would hazard a guess that the reason that this tablet was copied several times and has been passed down in history is because the Babylonians knew that those 2 entries were right, but they couldn't explain them. And they maybe figured that sometime in the future they could explain them. So you needed to preserve it. Because even when a scribe comes along to actually copy the original tablet, the original is now missing, by the way, but there's nothing sinister about that, probably just wore out. Even when the scribe came to copy it, the scribe's bound to ask the person that was asking him to copy it, is this right? And he'd have been told yes. So here's the conundrums. If we could solve the Venus tablet, then we would know the date of Santorini. On the other hand, if we knew the date of Santorini, we could solve the Venus tablet. So it's a case of watch this space. Thank you.
Thank you very much, Bruce. A fantastic talk, extremely well explained. Can we put our hands together? Thanks. And it's better second time round, I must admit.
oh, thanks for saying that, by the way. I knew I was a bit different in some places. And I think I was probably a bit quicker because I know that we've got a long night. You know.
An entertaining night, Bruce.
Yeah.
Right. Anybody on Zoom has any questions? If you put them on the chat box, perhaps Peter can call you out.
Wait a minute. Let me put my screen off, I guess. That's better, isn't it? Yeah.
Right here.
Well,
Yes, type message down there.
Horst would like to make a comment, I think.
Well, it's a question. So from the conjunctions, you worked out where the intercalories have to go.
Yeah.
If you compare with the moon, can that tell you which modern years those were?
Well, one thing I haven't done, Horst, which would take quite a lot of work, would be to take those preferred dates, or even a date that I might find that was better than them, and then go back and precisely work out all the months the way I described it and place it on there. And I might get a better answer. I'm not sure. There are difficulties with the data. Other people have pointed out as well. Some of the data points were transcribed incorrectly by the scribes. The cuneiform is so fine, as you saw on that first slide, that sometimes, and the way they do their numbers, they just put more and more little strokes. Sometimes that they'll take an 8 as a 7 or a 5 as a 6 because they look right, you know, to a tired eye. And in many places they were 10 out in their numbers because the 10 looks a bit odd as well, and etc. And people have tried to correct this, and I've looked at what they've done. But all of the data points I used, that I was comfortable with, shall we say, they were good data points. And that's why, and those two that I showed you in particular, that I can never get down to the value that they've got, no matter how low I make the Arcus Visionis, they worry me. And some people have said that maybe the orbit of Venus has changed slightly over the years, and NASA is unaware of this. Some gravitational effect somewhere, Jupiter perhaps.
Thanks for that, Bruce.
Thanks.
Alan.
Yes, Julian has a question.
Julian, right?
No, I just noticed in the tablet at the beginning, every now and then you'd see some little, I don't know if they're holes, kind of dots. There was maybe about 3 or 4 of them, and I was just wondering what they represented.
I can't read the tablet itself, but as I say, the way they did their numbers, you know how we have a different character for each number. 1 was a stroke, right, with a little blob at the top. 2 was 2 strokes with a blob at the top. 3 was 3 strokes with a blob at the top. 4 was 3 plus 1 underneath it. 5 was 3 plus 2 underneath it, and 6 was 3 plus 3 underneath it. So 6 would look kind of squarish, you know. But if it was a 5 and it was a bit funny, they might just look at it if they're in a hurry and put a 5 instead of a 6. So their numbers were just up to 9 strokes, and then the 10 was a different one, was a chevron.
Yeah, these little holes that I saw, they just look like something else.
Mm-hmm.
Some kind of separation. There was some lines, and
Yeah, I saw
the
that.
rest of it just looked like wee spaghetti or something.
I saw that, but I have to take their word for it because I can't read it.
Okay.
Yeah.
Okay.
It'd be brilliant. I'd love to read it. I'd love to read Egyptian hieroglyphs as well, but I think it's beyond my time on this planet.
Yeah. Thanks.
Yeah.
And John Morell's wondering about something.
Yeah, my question, Bruce, was as astronomers, we know lots of times it's cloudy in the morning and the evening.
Mm-hmm.
Have we got any ideas how they're allowed for clouds? Because obviously,
Yeah,
if I tried to observe Venus from here, there'd be all sorts of discrepancies. Is there any?
Now, there's a couple of things writing on that, which I've gone through in my mind a few times. Firstly, if I make the Babylonian calendar, it's true that I will make a precise mathematical calendar, right? And I could even be slightly wrong by one day when they did see it. But that all comes out in the wash, because it's not an error that continues, because every 29 days you're in a new, it self-corrects.
Yes.
On the point about clouds, yes, if they got to a point, I think it's 31, there is a rule. I think if it gets to 31, they go back to 1. Because they know that there was going to be another month.
Yes.
Because it's never less than 28 and it's never more than 31. So they go back. However, I mean, if they were observing this month in, month out, year in, year out, because they're seeing it 13 times a year, I'll bet you they knew from the kind of height in the sky that it was, in their area, that it probably was yesterday, if they had a cloud yesterday. I don't know whether they would then backtrack and say, today was the first day. Or even if it was cloudy, they'd say it was going to be one of these this time. Because they must have seen the rhythm of the moon,
Yes.
And I think that it's possible that they guessed the date if it was cloudy. But they certainly started a new month if they got to 31.
Because, of course, one of the current religions, isn't it? You still uses the moon. Moon is the start of the month.
Oh, and there's a lot more debate as well about that, because one of the interesting, and I said it a little bit earlier in the talk, you might have noticed I said, this is in Babylon. That was the demonstration I was giving you. We're 3 hours behind Babylon. That means that the moon is 3 hours older when it arrives here. And if it goes to America, for example, it's 12 hours at the other side of America, sort of thing. That means that the next day, the next month could start in America the day before it started in Babylon. And I don't know how Islam gets around that. I think they must specify a particular place in the world that is the date. Otherwise, they'd have a different calendar everywhere around the world.
Well, even different observing groups, of course, some will see it and some won't, because you're not allowed to use a telescope to see it. It has to be a visual
correct.
observation.
That's correct, yeah.
And, of course, one group with a good eyesight, less haze, will see it well before the others.
Yeah, that's another parameter that, they may have had people with eagle eyesight sometimes and somebody that wasn't with eagle eyesight at other times. But things like the Hajj and, Ramadan and all those, they are dated from that calendar and not from the solar calendar. It's very precise when they date those, which is why I think they've got one place in the world that crescent is meaningful.
Okay. Can we, in the interest of time, if we can just move on to another question?
Yeah, the next one's from Dave Craig. Interesting question.
Hello, Bruce. Okay, I was wondering what your thoughts were about why the people that wrote this down thought it was so important. What were they trying to, why did they think it was a mystery, or why did they think it was the thing that needed to be written down amongst all the other things they might have written down?
Well, because I think they saw those two readings that jump out at you when you start working with this tablet. Because they hardly sat down on day one of Ammisaduqa's reign, and sagaciously said, why don't we look at Venus, And then when he died, they said, oh, there's no point in looking at Venus anymore. They must have been looking at it years in, year out, and seeing the rhythm of it. And then along comes two readings that don't look right. Never seen anything like that before. So they preserve that tablet in case they can find out.
Yes, I took that point, Bruce, but what I was wondering is, why did they start doing it in the first place? You can only see that once you've done your 12 years of records, but why start writing it down? Why not just say,
just mankind? Mankind is interested in these things, and I think they probably worship Venus and Jupiter and all these things.
Well, okay, now if I just follow on a wee bit and think, well, maybe it was to do with something like taxes, and maybe somebody ran out of money and they had to hold the calendar and say, like the Europeans do, and they say, right, we'll stop the clock until it's all agreed.
It's possible.
Okay, thanks. That's a great talk.
Yeah, it was great. Mark, you have a question?
Thank you, Bruce. That's great as always. the idea of the volcanic eruption, is that something you've come up with, or historians using that as well? Because I was going to just say, because I was, you don't know the date of Santorini's eruption, but I had something in my head that you can actually date eruptions of volcanoes. I think it's something to do with argon 40
Yes.
eruptions and so on.
Yeah, a couple of points on that one. It came to my mind, as I looked at it, and I thought, if this is right, dust in the atmosphere. But when I realized later, when I reread the paper that Ken Thomas gave me earlier, and I pulled it down off the web. I pulled down a later one off the web, in fact, from the same author. He did hypothesize Santorini in that paper. He said maybe somebody should look at Santorini. I may have subliminally seen that when I was reading his paper, so I may not be original on that one. Well, not original, because he had it. This was 1972. What was the other point I was going to answer for you?
Yeah, I thought, there is a way of dating volcanic eruptions.
Oh, yes, dating of volcanoes. Yeah, it's really interesting and that's why I was very specific about the fact that this thing went bang. It seems that when it goes bang, it doesn't leave a very big footprint. Now, they had a dig that in 2002, they found on a dig for Santorini, they found a village that had been obliterated, and there was a burnt olive branch in that dig. I said, whoopee, they quite rushed off and did a carbon-14 dating on this piece of olive branch, and they got an answer, 1613 plus or minus 7 BC. And they published it. And I saw this paper and thought, great, we're getting somewhere now, and I could fit Ammisaduqa to anything with years of 8, So, and then I kept reading, and there's another paper later from Leeds and someplace in Canada, and they said no, they did that carbon-14 completely wrong. it's not that date at all. And there's been another paper, which was an ice core paper. That's a good one, and they're suspicious that they've got a reading of 1645 BC. So it's a bit, there probably isn't enough dust to actually get a big ice core dust. It's really weird. The footprint is, because if you look at Vesuvius, for example, the footprint's brilliant. They know it right down to the year 79 AD. But it was a pyroclastic flow and quite different. And it locked everybody in, and they can get the carbon-14 dates. So it's very odd. It's frustrating, actually.
Yes.
Okay, we need to move on to Alan has a comment to add.
Comment question. I'm muted. Okay. Venus can pass up to 8, in fact, over 8 degrees north or south of the sun as it goes through an inferior conjunction. From our latitude, at least, that means that there are some days around the time on some inferior conjunctions when you can see it in the evening sky and in the morning sky over 2 or 3 mornings. This may not apply at the latitude of Nineveh,
Babylon.
Yeah. But I wonder if that has an impact on your calculations.
No, my calculations were done at Babylon with the Babylon latitude and longitude. I did everything at Babylon. And indeed, your point is a valid one, because the Aleph algorithm, they've adjusted those algorithms because they don't get the right answer up at our latitudes. It was all done for places like Babylon, to try and solve these mysteries. But they need a slightly different equation at our latitudes. It doesn't. It's ill conditioned.
Yeah.
Mm-hmm.
And we have a question from Tomoko. Do you want me to ask the question? Tomoko's saying that there was a lot of archaeological work in progress to try and improve the estimates of his dates. Has this narrowed the timescale at all?
That's a question to me just as you've read it.
Yep.
I don't think so, because I had hoped that when I saw this 1613 plus or minus 7 BC, but having later seen an ice core guess of 1645 BC, I think, we're seeing numbers that are spread by enough that we're not really homing in heavily. But oddly enough, 1645 BC is very close to the 1646 that they like best. That's quite good. But you know, again, it's a bit like some of those observations that I was looking at. How can I believe 1645 rather than 1613? Because they both apparently did this in a scientific way.
And then we have Graham Rule. Graham, do you want to make your comment? I don't see it.
The answer is no, anyway. I haven't read Graham McNaughton's book. This is not British Leyland, where the answer is yes.
For those that didn't see it, Tomico is Ken Thomas, by the way.
Yeah, he did put that up. Yeah.
Well,
okay, well, that's over to YouTube.
Yeah. Anything, Will?
No, there's it's been a very enjoyable chat, but there's no questions from YouTube. I've actually just got a comment, a little comment. I just wondered, kind of a question, if there was any evidence of any sort of mountaintop observation areas in ancient times from these tablets. Thinking currently, I do understand with Ramadan and stuff that I believe they have a fighter pilot who goes up way above the clouds and first sights the crescent of the moon. That could be one thing. And I just wondered if these things could be linked, you know, they could have someone who's observing maybe very high up that might affect things. Just thinking aloud here.
Yeah, they don't know where the observations were taken from, actually. And some people have tried to work out the solutions from 2 different latitudes and longitudes inside Mesopotamia. There's talk about the fact that in Babylon, when you look west, you get a better scene than when you look east, because there's some mountains apparently, and they worry about these things that might have affected it, but it doesn't seem to have. When you look at the numbers, they look pretty good. So the evidence is sketchy on that one, if anything. I don't know about the fighter pilot, by the way. Certainly high precision crescent moon.
Bruce, can we thank Bruce again for putting so much time and effort, and the work he's done is tremendous and very interesting. Thank you very much again, Bruce.
Thank you.
Excellent. Right, so if I go back to sharing my screen just for a second. Okay, present. We're going to move on to Scope Talks. I've just got one thing I want to say, because last night I went out into the garden and every time I tried to take an image, something got in the way. That was probably the worst of them all. So I've sent that off to Andy Lawrence, who's using it in a talk tonight about his losing the sky. So that probably leads on into some observations and some of the equipment we use. So I'm going to hand over to Pat now. If I stop sharing, Pat, and you can start.
Okay. Can you hear me okay?
I can.
Yeah, okay. Let me share my screen. Hopefully you can see my screen okay.
I can.
Okay, so what I'm going to talk about is the ASI Air Pro, which really it's a device that eased my route into astrophotography. And I think hopefully for anyone on the call who maybe as an observer who's thinking I'd like to get some astrophotography, or someone who's starting in astrophotography, then I found this device really helpful to kind of get through, at least getting up and running. So I'll touch on, a little bit where I came from, then I'll go through what the ZW ASI Air does, and then hopefully I'll do a few kind of quick demos of the functionality. So I joined the ASE back in October, just kind of middle of lockdown as it was now. I've always been interested in astronomy and photography, but never really brought the two together. I don't really have any observing experience. I had a telescope when I was about 12. But I've been quite a keen photographer, but more just landscapes around the place. But last November 2019, I bought a Canon mirrorless camera, and that Christmas, my son bought me photographing the night sky as a Christmas present, and that really kind of prompted me to to kind of look up at the sky. I'd never really, although I've been interested, I've never really pointed my camera at the sky until that point. And frankly, I was amazed at what you could pick up with a digital camera on a tripod. They're really impressive. Loads of stars that you can't see with the naked eye. So that really kind of got me thinking a little bit more about astrophotography, and I did a little bit more reading. But then kind of the summer came along, and as you know, at this latitude, there's not a lot of daylight, so that kind of put to side. But I started to kind of think, what would it take to get into this a little bit further? So I started to look at, how do I get more than just taking, Canon shots of the sky? I wanted to get more deep sky, galaxies, something that was a bit more interesting. But then I started to kind of look at, well, what was it going to be involved? So all this software that potentially you could use, or you would possibly need to use, a lot of it great software, but when I started to look at the details, it began to get a little bit complex and a bit kind of compelling. And then you have all the hardware, which is from a mount to trackers to computers to so it was all getting a little bit, maybe I won't do this. It's going to be too much. I'm going to spend all my time, kind of bringing stuff together, cables everywhere, sitting in the garden, trying to figure out all these different features. And then I came across the ASI Air, and basically what this does is it effectively pulls all this together into one box, which made it much easier. Now these tools are great, and I think what the ASI Air does allows you to get an intro, and then obviously as you get more experience, you can move on to these more dedicated and more complex tools. So the good thing about the ASI Air is it's all controlled from your phone, which makes it quite very convenient. So what is it? What can it do? So it's a Wi-Fi control device. It controls all your cameras. It is made by ZWO, so it's focused on their hardware, but you can control it from an Android device or your iPad or your iPhone. It also allows you to use some DSLR cameras and non-ASI astronomy cameras, so it's not solely for the ASI or the ZWO family, and it covers the end-to-end sequence of what you need to do. So polar alignment, guiding, plate solving, all in one box and all through this kind of integrated piece of software. So it's been around since 2018. The one I have is the ASI Air Pro, which was released in 2019. But there have been regular, probably quarterly software updates. So it's not a static device. It's constantly being added to, and was updated a few months ago. It's actually based on a Raspberry Pi running PhD2 inside. So you could probably build it yourself. I mean, I think it's a pretty standard Raspberry Pi device inside. But when I found out, I thought, will I, won't I? And I thought, no, I won't. It would kind of go down. And the good thing about it from my perspective, and also certainly through the winter, is once you're polar aligned and focused, then everything else can be done inside. So basically you get your polar alignment, get your focus, and you're inside in the warmth, looking at the cold outside. So you don't need a laptop. You can do it all from your Android device or your laptop or your iPhone. And it's all one package. So everything works really well together. That's in my experience anyway. But it also runs on a laptop emulator, which hopefully will work when I show it in a moment. So if you did want to use the laptop, or you wanted just a bigger screen, then it does work on the BlueStacks Android emulator. So when you order the ASI Air, this is what comes in the box. You get the device, which is a nice metal case. You get a number of cables, which basically are enough to get you started. And you get a memory stick and the instruction manual, which is not great. It doesn't really tell you very much. So there's a lot of better sources online. One thing that kind of surprised me is it didn't come with a power supply. So, there's quite a lot of people online get their ZW Air and realize I can't power it. So there's a lot of kind of people complaining about why don't they put a power supply in? But it's a standard power supply readily available from Amazon. So if you look at the device, looking at the back, there's the software is on a standard SD card, 32 gig, which you have about 20 gig available for storage. You also get with the package a 64 gig USB stick that you can use for additional storage. It's a standard 12 volt 5 amp power supply, so very, very cheap, available on Amazon. And also, you get this Wi-Fi state reset button, which is very handy if, like me, I use it all the time at home. It's all set up to be on my network. If for some reason I decide to take it off into the hills and I don't have my home network, then I'm basically stuck. So the Wi-Fi reset allows it basically all to get back together, and then you can actually use the Wi-Fi on board very easily. From a power and connectivity point of view, it has 4 power outputs for your camera, for your dew heater, and these can be turned on and off if in the app if you need. It also allows you to connect your DSLR, so it will control the shutter speed, shutter release for you. There are 2 USB 3 and USB 2 ports for your camera and for storage, and also a RJ45 for your home network. It has wireless built in on both 2.4 and 5 gig channels, but the wireless signal is pretty poor. I think because it's a metal case, there's no external aerial. So it works great if you're standing next to it, but if you kind of move too far away, it's not great. But it does also have a wired connection, so you can connect it back to your router, and you can also bridge from the Wi-Fi on board into your home network. So it is actually very accessible. My current setup, I started off with, as I said, my Canon on the tripod. I kind of then bought a Skywatcher Star Adventurer, which I used with the Red Cat, really good. But I found with the Skywatcher being in the centre of Edinburgh, I found it very difficult to find targets, exactly get on target, because there aren't that many stars. So doing star hopping is quite a challenge. So I would spend a lot of time just off the target and then trying to kind of I'd spend an hour trying to go on the target. So I think with lockdown, not going on holidays, I thought I'll treat myself to the HEQ 5. So what I have is a Red Cat, which is a 250mm refractor, ZWO equipment, for the guide scope and for the camera. I was starting off with nothing, so I decided just to stick with ZWO. And basically, this is what I have outside. So when I'm outside, I have a power line extender which I plug in, which basically allows me to bridge onto my home network. So once I'm back in the house, then the signal is going through over the Ethernet connection into the house and works really well. It does have the kind of standard workflow that you would have for astrophotography. So features for setting up your devices, pore alignment, focus, choose a target, set up guiding, and image sequencing, and it all works very smoothly together. It's a nice interface. So once you turn it on your phone app, you get presented with the kind of entry screen. And basically what it does is it pulls data from your phone. So it knows where you are, and it syncs that up to the mount. And it also pulls in data that it can see about what you have actually connected to the device at that point in time. So very easy. So let me just, so device configuration is the kind of first thing, and hopefully you can see this as it disappears. So this is the app running on the BlueStacks emulator, just so I can share it here, but I usually just use it on my phone. So this is the kind of home screen. You get the current temperature, which remarkably for Edinburgh in our kitchen is 24 degrees. You can see the gain, and then along the top you have the various control options. So you can control the Wi-Fi setup, so you can configure which Wi-Fi channel you want, what your home network, whether you want it to be on wired Ethernet, and various other features there. You can then control your camera, and obviously it will detect that I've got the 183 MC Pro. It picks up the focal length automatically. You can control the gain from here, so basically just a slider back and forward. You can turn on your cooling. If you turn on your cooling, it will allow you to then choose the temperature for this camera between down to -40. And then there are some other advanced settings which at the moment I haven't actually explored. Guide camera, chooses the guide camera, allows you to pick up the focal length, allows you to do the gain, set up your calibration steps. It also allows you to set up your dithering, so you can all do this in the app. And then on the mount settings, it will again allow you to choose your mount. I'm using an EQ mod cable. And again, it picks up the location from the phone and basically syncs it to the mount. It handles meridian flips. My scope, I don't need to bother about that. It's not long enough, but it does work pretty well. I tried it out a few times. And then obviously tracking and obviously kind of going back to the home position. It has the ability to control a filter wheel and also a focuser. I don't have these connected, so they're grayed out for me. But it does use the ZWO filter wheel and ZWO focuser. Storage, you can either use the onboard storage, the SD card, or the USB that you attach. And it's got some nice features on the storage. So if you look at it will organize your files on the device and on your storage, automatically. And depending on what you're doing, if you're shooting a video, if you're just doing a preview, which is just basically a snapshot, or auto run, which is basically a sequence, and I'll touch on that in a minute. It basically puts it into folders for you. These are not great images, but you'll see the point. So there's a big kind of horrible thing there. But so this is basically the image that you would get. And when you're taking a shot, every time it takes a shot, it will display it onto the camera. Some nice features here. It can do plate solving, so you can basically figure out, am I on target and what targets can I see? And another nice feature is this go-to functionality. So what it will do is it will plate solve the image and move the mount to that image. So if you've maybe centered on a target and then moved it around to get better framing, it will actually do that plate solving and basically give you back what you had before. So quite a nice feature. And then on here, you can obviously control the mount manually, or you can put in the array and dec coordinates directly. Another nice feature is it has a built-in database of objects. So you can basically search, I think it's got about 10,000 objects. It has, it's grouped them into, NGC, Messier, or whatever. It has some interesting facts about the object if you want. And then obviously it will tell you where is that object in the sky in terms of its relative altitude. And if you want to then go to that object, then you just click on the object and click go to, and it will slow your mount to that target. So I think that's all I had on this. So if I go back to my slides, let me just go back into presentation. So one of the really nice features of this device is its polar alignment. So basically, at the beginning, you do your polar alignment, and hopefully this will work. Yep. So basically, what it does is it does a plate solving. So you basically align your mount, with the compass to north. It will do a plate solving at that. It then rotates the axis to 60 degrees. So then it does another plate solve at that point. And I'll just skip past that. There we go. So it'll do a plate solve at that. And the good thing about this is often what I found is that when it does the plate solve for the polar alignment, I can't see any stars in the sky. It's pretty good at picking out the stars. So you can get an early start. Once it's done the plate solve and figure out, where you are, it comes up with this effectively target with the polar north celestial pole in the middle. And basically you have to use your auto bolts to move the yellow dot onto the green dot. And basically it's giving you how far off you go. It starts at 30 degrees and then goes down to 1 degree. And then as you get closer, it will eventually once you get in within 2 minutes, it thinks that's fine, that's close enough. You get a nice happy face. And what it will do then is it gives you a little kind of firework of well done. And basically you're now polar aligned. So really great. I've never used the built-in polar scope on the EQ5. So this allows me to get polar aligned without kind of kneeling on the grass and trying to creak my head down at some unhealthy angle. Once you've done polar alignment, it then allows you to go on and do focusing, which is pretty straightforward. So again, you will pick a target. In this case, I picked Mars because it was bright at the time. I wouldn't normally polar align. I wouldn't normally focus on Mars. does the same thing. It will slew to the target. It will then basically get onto the target. You move this little green box onto your target, and then you press the plus sign here. And what that will do is it will then bring up the focusing box, which is basically a live view of the target. So you can adjust your focusing and it will adjust it in real time, so you can see whether you're in focus or not. I use a Batinov mask, which will appear in a second. So not a great shot, but normally on a star it's much crisper, as you can see down here. So basically, you know, it takes very little time to micro adjustments, get your focusing right, and you're effectively done. The next thing is guiding. So once you've picked your target from the database, you would slew to the target. You would then do guiding. So again, this is PhD2 in the background, but again, works really well. So you basically click guide, click on the little chart here. It brings up you know, the kind of standard graph that you might see on PhD2. It will start taking an exposure. You click this kind of circle thing, which basically loops the guiding. And then once you've got the image, you click on the little target, and it basically will pick the target. It will pick a star of an appropriate brightness, and then, you know, you're guiding. And then once you're guiding, you can go back to the main screen and start your sequencing. So once you've got your guiding set up, let me see if I can go back to my other window. Once you've got your guiding set up, you can then choose your sequencing. So what do you want to shoot? How long do you want to shoot for? And basically, you can add, let me just get rid of that. Yeah. So you can basically add a sequence. So you can choose your exposure length from these preset ones, or you can enter it manually. You can choose your binning. How many exposures do you want? Do you want lights, bias, flats, or darks? If you had a filter wheel, it would give you the option of which filter do you want. So you can basically add, you know, filter 1, you know, add another one, different sequence, filter 2, and so on. And then once you're done, you would just go back to here, click start, and it will start doing that sequence. And when it's finished, each image, it presents the image on the screen, so you can confirm, am I on target? Has some clouds rolled in? And you can do this. This is all being done from your sitting room or your kitchen or wherever you're doing it. And so you get that image, you know, refreshed each time, which is very handy. So other features it has, it does live stacking. I haven't used that myself, but it does allow you to basically stack in real time. You do need to kind of set up some darks and some flats, but it only does a kind of master dark and master flat. I haven't used it, but if it's a feature, if you're at a star party and you want to show somebody, you know, what the image looks like, then it does it, and apparently it does it quite well. It also does auto exposure for flats. So if you're doing your flats, and I use just the t-shirt method, it will work out the exposure of the flat, so given a reasonable exposure, and then it will show you that exposure, so you can confirm, does that look, you know, what I want, and then you can use a sequence, as I just shown, to take a new set of flats. It does plate solving, so not only can you it will do plate solving for the polar alignment, it will also do plate solving, allow you to then sync that to something like Sky Safari. So Sky Safari has a much larger object database, so, you know, and it has a lot more stars. So the good thing about Sky Safari is that you can link it with ASI Air and then do some fine tuning on your framing. So if you want, what the ASI Air will do, will center on a target. If you want to be slightly offset from that, or you want to kind of, you know, change the orientation, Sky Safari has a lot more objects that you can pick that will precisely center your particular target. It has 4 video modes, which I haven't used too much, which I've done for a few moonshots. So basically different video modes. So a very flexible device, everything in one box, which works really well. So it's mobile, it's on your phone, it's on your tablet, it works really well, it's quite fast. All of the features are integrated and they work well together. There's a logical flow through the process, which is if you're starting out, you know, it helps you just kind of get to that point where you can feel confident that everything's doing what it should do. One of the great features for me is it connects to your home Wi-Fi. So once you've done the bit you've twiddled with the poor alignment, you can go back inside and, you know, be nice and warm. It does give you the end-to-end workflow. It handles the meridian flip really well. You know, I've seen a few folks on the chat having problems with meridian flips. I've only done it a couple of times, but it seems to work. It's regularly updated. I'd say probably every quarter there's some new updates coming out, and there's a very active online community. So you know, if you're thinking about something, somebody somewhere will have the answer for you. It mainly works with ZWO accessories for focuser and the like, but as I say, it does kind of work with other DSLR cameras as well. Guiding doesn't have multi-star alignment, which for me hasn't been an issue, but I have seen people complaining about that online. As I said, the Wi-Fi range is not great. There's no mosaic feature, but I think that's planned. And it doesn't support, it supports many DSLR cameras, but it doesn't support the new Canon CR3 format, which is the newer RAW format on Canons, which unfortunately was what I have in my mirrorless camera. So I had to buy a ZWO camera a bit earlier than I expected. But overall, for someone starting out on astrophotography and not wanting to get sucked into the complexity of all of those great applications and all that hardware, it's a great way of basically bringing it all together in a logical package and allow you to get imaging rather than kind of fiddling about with cables and trying to figure out what you're actually doing. So for me, it was a great find and I think helped me get to imaging, which is what I wanted to do sooner. So hopefully that was interesting.
Excellent, Pat. Can we thank Pat?
I'll stop sharing.
If anybody who's not seen any of Pat's images, actually go on the Flickr page because they're incredible. We've had some great images posted recently, and Pat's is certainly amongst them.
Thank you.
Any questions for Pat?
Obvious question, Andrew, to Pat. How much?
It's £289.
Yeah. I might get one in 5 years' time.
Can I ask Pat a quick question?
Yeah.
One thing I think, seen that people have said there's a problem with backing up the software. The only real way you can do it is take the SD card out and put it in a different computer that will back up the entire SD card.
Yeah, there's well, I bought a £10 SD card adapter, USB adapter from Amazon, and basically just copied it onto my PC. There's a process outlined on their website. It's pretty straightforward to do that. And they do recommend you do that because your license is on that SD card.
Yeah, I think the only problem, like all Raspberry Pis, is you end up with a 32 gig image, don't you, every time?
Yeah.
So you need a fair bit of storage on your main computer to keep it.
Yeah, well, once you've backed it up, then it's fine. I mean, I bought an extra SD card so that I can stick one in. I didn't have to reload it. So.
Okay, thanks.
Well, I must admit, Pat, not having to get in the kneeling position and the crooked neck in the semi-dark does sound attractive.
Crooked neck and damp knees.
But I do appreciate spending some time in the cold, and I think for some of us, doing your sort of putting up with a bit of adversity makes the result more worthwhile. But each to their own. If there's no more questions, any more for any more, we'll move on to Hugh.
Yeah. Can I just first of all check?
Well, first of all, Hugh, we can't hear you very well.
Give me a second. Up to speak. Hello. Over there.
That's a little bit better.
Yeah. Can I ask someone to do the slides, because all the way through Pat's talk, my screen was dropping in and out all the time. So I just don't know if it's going to do anything.
Where are your slides, Hugh?
They're either on, I've got them on the Facebook page or on the Flickr, my own Flickr files. I can try, but you know, if it drops out, then I'm scuppered.
Right. I'm not sure we can. Mark, can we?
Give me a second.
No, I actually couldn't see Pat for something like 10 minutes because my screen just kept dropping out.
Okay, I can do it. Where do you want to
Alright.
start, Hugh?
So share screen.
Well, I'll share screen. Yep.
Let's see if we've got this right again. So I've got my slides showing up to me.
Well, I thought you wanted me to share it.
Oh, sorry. Yeah. Please, you do it. Yeah.
We'll give it a go, and if it fails, we'll postpone it for another day. But let's know it done.
Which one do I start at, Hugh? The one that says double stars? Or?
The one that starts as it's an index, just an index page.
Okay.
They are all in the right order.
All right, got you.
Yep.
Yeah.
Okay.
Just a minute.
Yeah, sure. While you're doing that, just with reference to Andrew's shot of the, I think it was a galaxy. I think Tim had commented this afternoon that he'd seen a few Starlink satellites. There's actually about 1,338 of them up in orbit at the moment, and that's only about 10% of what's expected. So it's really going to be pretty horrendous.
Can you see that okay?
Not yet.
I can, Matt.
Yeah, it's looking good.
Yeah. Oh, yes. Sorry. Yeah, that's fine. Absolutely fine. Right. Okay. So I'll just get started. So I'll go through the index very briefly. There's just a few things going down it, and I'll, as we move on from each slide, I'll maybe add in a couple of comments as well. So in the spring of, sort of next slide, please, Mark. So yeah, in the spring of 2014, I was chatting with Fiona at work, and she showed me the star chart app on her phone. I downloaded a copy, and a couple of days later, never looked back since. I really hadn't taken much interest in the sky up until then, apart from seeing the Neil Armstrong step on the moon, the occasional shuttle launch, and watching Patrick Moore on the sky at night. So I had a pair of Samsung 7x25 binoculars, which I still use. And most nights from my bedroom window in Canaan Lane in Morningside, viewing southeast or southwest, and facing the other way on the stairs would be northwest to northeast. I don't know if other people have done this, but I've started printing off wiki lists of constellations, stars, etc. Within a year, I'd created my own catalogue, that's it, under the binoculars, of about 2,000 stars that I'd seen through those binoculars and confirmed with the star charts on the phone. Funnily enough, I don't use that anymore. I've stopped doing that. So then got hooked on SpaceX. I think most of us did in the early days, with their attempts to land the booster rockets on the drone ship. I think it was the Dragon, Cargo Dragon CRS-4 that I first watched being launched live, and the rest is, as we know, is history. So where was that going? It was going up to the ISS, the International Space Station. So of course I did took lots of interest in the ISS. Next slide, please. Yeah, can't even read it. So yeah, I realized that I wasn't, that I was completely hooked, so decided it was time to get myself a telescope. So went along to Cameratics and ordered up the Celestron Astromaster 130 EQ, which is the one that I've used and still do almost every night, and it still produces reasonable results for me. sorry, I can't even read more. Oh, there we are. It's in front of me. I started going up to the Royal Observatory to the lectures on a Monday night. And when I was chatting with Ali and Martin and William, I asked them how many constellations they could see from Edinburgh. They said they had no idea. And of course, astronomers generally aren't really that bothered about the familiar stuff. So far, I've seen at least parts of 56 constellations, and I know of another couple that I probably have as well. It was about this time when I became a carer for my parents, tuck them up in bed at night, and once they'd settled down, I would nip up the Blackford Hills or the Braids with my binoculars and my iPhone and start charting the skies, and spent many, many, many nights on the hills getting cold. The next thing that happened was, where are we? Yeah, so I got the telescope. I couldn't even, I think like most people, couldn't even find the moon the first time, even though it was a full moon. Suddenly realizing that your field of view had reduced dramatically. So that was a start of it all. I got myself a really cheapy finder scope on eBay, and it was about 10 quid. You could just about see the Pleiades through it. And that's when I started making my first bracket to hold that. I also gradually built up a stock of lenses and Barlows and filters, etc. And funnily enough, nowadays, I practically don't use any, maybe 2 or 3 of them. That's about all. So where are we? D. I then joined the ASE. D, let's see. Do you want to move on a slide, Mark? That'd be great. No, other way. Yeah. So this is the Mark 1 setup, and on the right-hand photo, you can see the basic finder scope with the bracket I put on it. The ring round the telescope is supporting one end of a long strip which tucked in at the end of the telescope, and I put a sort of almost like a leaf spring which supports my Canon camera, which I'd bought by then. And I could adjust the elevation of the camera to get the right angle so that it matched what the telescope was seeing and vice versa. I could also swivel it left and right. That was a bit more basic. So what happened after that? Yeah. Yeah. So I then started coming along to the ASE. The first night I went along, it was the talk by David Wood about the Saturn V rocket, which I think blew everyone away that night. It was just fantastic. And I don't know whether it was a good thing or not, but the ASE seemed to be a nice friendly bunch. You must make a note of not to be so friendly next time. Also went along to the ASE Open days at East Fortune and then up at the observatory, which was great fun. So yeah, you got me hooked quite quickly. Next slide, please. So it should be the lunar eclipse one, which is number 6. Yeah. So I'm seeing the lunar eclipse on my phone. Sometimes my laptop is a bit slow. So this was on the, I noted it down. Sorry, I've lost the date of it. 29th of September, I think. It was a Monday night. And that was a lunar eclipse that we could see from Blackford Hill. And I was aware that there were people back at the wall of the observatory. But I was out on the little bump just south of the car park on my own. This shot was taken using the Canon through the lens, through the eyepiece of the Celestron. And I took a series of images That's the first one I've shown. I haven't shown any others. The rest are on the old Flickr site. So now then, next slide, please. So it should be F. Yeah. So yeah, say a little bit about the Canon is a 500D, which I got from Cameratics. As I've shown, I've made a piggyback bracket for it. Now, the funny thing was that I brought the telescope along to one of the ASE meetings, and John Watson showed me how I should have been using the telescope. I'd been using it completely wrongly. Unfortunately, not long after that, the axis seized up absolutely solid, and I've never been able to free it again. So I reverted back to my tried and tested method of X and Y and allowing the stars to drift past sort of in a transit sort of method. And as you know, it's worked reasonably well for me over the years. So yeah, that was fine. The great thing with that telescope is that I could take it in the back of the car and I could set it up within 15 minutes at basically any location, including down at the farm, Pennycook, the Pennycook to West Linton Moor, Midmar, Fife Ness, and obviously at Scout camps as well. Now, where are we? E, F, F. Yeah. So the next slide, please. It should be the Mark III photos. Yeah, that looked like it. Just, yeah, that one. So this was the Mark III. More brackets. There's the decent 50mm finder scope. Let me see if I can open it up. By that time, I had bought the Altair Astro CCD camera or CMOS camera, but hadn't started using it. So it's in a dummy bracket. I think it was just to show it in place. I've also got the Telrad on there somewhere. And by that time, I'd also got my 500mm mirror lens, which I should say now has been my main tool. It was what I used time and time again with the camera piggybacked. I would go out, in particular to the Pennycook to West Linton Moor, and sit for half the night just taking images of the sky. And actually, there's still images I've got that I almost couldn't compare and get a better shot with the telescope. So it was a good lens. It's done good service. Now, on we go. So the next shot, please, Mark. I think it was, yeah. So this is an interesting shot that I took. Some of you will remember that I got quite keen on the iridium flares. I won't go into all the details of that, but I remember showing this slide at one of the meetings, and I didn't get the chance because I think I had the usual last 2 minutes. There's a double star up there. I'm going as fast as I can. That double star wasn't one I've double checked since then. It's not one that I'm interested in, but I had made a note of it at the time. So then I moved on. Next slide, please. I should say there are still 29 Iridium satellites up there, but difficult to get flares from them now. The Mark IV, again, more versions of toys. Next slide, please. Yeah, so moving on to buying the Skywatcher 200p with the EQ5 mount. Next slide. So another few toys, the solar filter, the Celestron phone grab, which I know that Peter has as well. It's excellent. It's so easy to use. Yeah. Next slide. Oh, more brackets. There's a Telrad showing. Yeah. Okay. Skip that one. Next one. Yeah. And if you, let me see. Go. one back from that, please. No, no, it must be the one after then. Should show I should be able to see RVO now. Okay, it doesn't matter. So yeah, there we are. So that was Ruther Valley Optics down in Ruther Valley, funnily enough. Great place, great guys to deal with, and happily recommend them anytime. It was a long drive home though. Next slide. So yeah, first lockdown. I'm on the next page already, gosh. So the first lockdown started. I brought the old 5-inch into the flat and started to realize that I was able to see lots and lots from town. So I could look south to west and north to northeast, getting rough images of open clusters. Now done about just over 100. So the best viewing I had, next slide. Okay, I'll do this just while it's showing. That was me taking my big interest in the ISS during the first lockdown. I've got the whole history of the ISS, the building of it, etc., and all the arrivals, departures, and EVAs, all in a spreadsheet. We've got 75 pages of it. Next page, next slide, please. And again. Yeah, so this is the mount for the solar viewer, and this is the setup when I was looking at the sun on a lovely sunny day down at the farm. So there we go. Okay, and again. Okay. Yeah. So we got to the Christmas in the second lockdown. So I brought the EQ5 mount into town and suddenly realized a huge difference. And actually I could see stars that were staying still, and I was able to take better images, and yeah, definitely improving on things. I can't align on Polaris because I can't quite see it, but my alignment's getting better all the time. And also I've discovered some more settings for the CCD camera because I was only getting very short AVIs. Now I've improved on that. Next. Yeah, that was with the 500, the Canon 500 from up in the Braids. I think we were all dotted around, and it really was exciting seeing that for the first time. The next shot is M13, and it's one of my favorite shots. Again, next one. That was with the 8-inch, I should say. This was with the 5-inch from the flat. And this was the one I was able to show the neighbours on the balcony. I've just had a sign saying tap to speak. Try that. No, I'm still there? Yeah. So what are we on? The dumbbell? That was the first nebula that I had to wait for to appear, and yeah, great feeling when it arrived. So next slide. Yeah, a bit over the top there. Next. So this is what I hide my laptop in if I'm outside, and on Christmas Day I improved the bracket on the right that holds the hand controller. Next slide. This is basically the setup that I use most of the time in the flat up until Christmas. Next one. And that's what it looks like out in the balcony. Next one. So this is a composite of Sigma in Orion. It's a multi-double star, and it's probably the one that got me first hooked using the Turn Left at Orion catalogue. And that took quite a long time to figure out all the different double star setups there. Next slide. So double stars, yeah. So I'd been wondering what particular niche I wanted to sort of get myself involved in, and realized that double stars was one I could manage reasonably well. And there's a lot of material to look at in that. I'll always maintain that I have no scientific or astronomical training, but I do like the challenge of basic research and being able to back it up. So I'm learning to have the greatest respect for astronomers from the past whose optics were perhaps poorer. They started off just sketching, but very accurately and patiently and measuring. They didn't have plate glass photo images to work with. They had no computers, no go-tos, no CCD cameras, no internet, and certainly no zooms. So checking out each set of doubles, I can mark off whether physical or not, the magnitudes and the color specs, position angle and separations using Stellidope and Simbad. So in summing up, now, like everyone else, I'm just itching to get restarted again using the 8-inch out of town. And I'm still amazed that with the equipment I've got, that I can show traces of galaxies 200 million light years away from here in town. Thank you. Oh, thank you, Mark.
Thank you, Hugh.
Thank you.
Excellent. Excellent, Hugh. You said 15 minutes and you're bang on.
Hey.